Assume that two cards are drawn from a standard 52 card deck. If the cards are drawn without replacement, find the probability of drawing a diamond followed by a non-diamond. Now remember, this followed by is important. That implies an order, that you're going to draw a diamond followed by a non-diamond. In other words, what we're really trying to compute is the probability that the first card drawn is a diamond and the second card drawn is not a diamond. Now, forgetting that temporarily, what if we tried to picture this whole situation in a tree diagram and just write out the whole tree? If we did that, forgetting about what we really want to draw, if we're just looking at what could happen, the first draw could either be a diamond or not a diamond. Now, there are 13 diamonds in the deck. There are 13 of every suit. So the probability of drawing a diamond on the first draw is simply 13 out of 52. If there are 13 diamonds in the deck, that means that 52 minus 13, which happens to be 39, there's a probability of 39 out of 52 that you don't get a diamond. So if you're just looking at drawing from a deck of cards, the probability of getting a diamond is 13 50-seconds, and the probability of not getting a diamond is 39 50-seconds. Now it does turn out that both of those reduce. 13 divided by 52 is 4, so 13 50-seconds reduces to 1/4. And there's also a 13 that will divide out of the top and the bottom for the 39 50-seconds. So 39 divided by 13 is 3, and 52 divided by 13 is 4. So after you simplify, the probability of getting a diamond is 1/4. The probability of getting something that's not a diamond is 1/4 on the first draw. Now we're drawing without replacement. That means we're not putting the card back. So if we look at our second draw, we've got to decide what happens based on the fact that one card now is missing from the deck. But we also realize that we're looking at this particular probability. And we're looking at the probability we get a diamond on the first draw and something other than a diamond on the second draw. So we're really not even interested in this lower branch here, because that's not what we're doing. We're looking at the probability we get a first draw of a diamond. So even though you could draw the whole tree, we're only interested in the branch that has the diamond first and the non-diamond second. So why draw the whole tree when I'm only interested in that single branch? That's what my point is. You could draw the whole tree, but we don't really need it. Well, once you see that, our next job is to figure out what the probability on that last branch is. That's the probability of drawing a non-diamond after having already drawn a diamond. Well, that's easy enough, because after the first card was drawn, there are only 51 cards left in the deck. There were 52 cards, one was drawn, that leaves just 51 cards in the deck. And we also know that the first card drawn on this branch was a diamond. So that means all 39 non-diamonds are still in play, but you're only drawing from 51 cards. So the probability of drawing a non-diamond after a diamond has already been drawn on the first draw is 39 over 51. A word of warning here, most people think 51 is prime, but it's not. So anytime you see 51 in one of these probability problems, be careful, because 51 is 17 times 3. So keep that in mind. That 39 divides by 3 and that 51 divides by 3. Now, like I said, we don't need the whole tree diagram. If you wanted to complete the other branches, you could, but we're only interested in that one. We know that when we're doing the probability along a branch, we simply multiply, so the probability that the first card drawn is a diamond and the second card is a diamond is simply the product along that branch. So it'd be 1/4 times 13/17, which is 13/68. I would like to mention that we could have done this whole problem without drawing a tree diagram. You could have gone straight to the product rule for probabilities. And if you did, you would simply have to say the probability that the first one is a diamond and the second one is not a diamond is the probability that the first one was a diamond times the probability that the second one is not a diamond, given that the first one is a diamond. That's what the product rule for probability says. And then you can say, well, what is the probability that the first one is a diamond? Well, you've got 13 out of 52. It's actually this number here, 13 out of 52 reduces to 1/4. But if you didn't draw the tree diagram, you just have to figure it out. And the probability that the second is not a diamond, given that the first one is just this other number on the second branch. You just figure it out if you didn't draw it. So if you wanted to try to solve this problem without drawing the tree diagram at all, it's certainly possible. My point is simply that the tree diagram helps you visualize the product rule for probabilities, making it easier to do. Assume that 2 cards are drawn from a standard 52 card deck. If the cards are drawn with replacement, find the probability of drawing a diamond followed by a non-diamond. First thing you should notice is this is exactly the same problem we just solved, except that now we're drawing with replacement instead of without replacement. That has very little effect on the process. So if you look at what you did before, this is our old calculation, we ended up multiplying 1/4 times 39/51, and we had to reduce the sample space from 52 to 51 because the card was not replaced. The only difference now is that we replaced the first card before we draw the second card, so that 51 is 52 now. Otherwise, it's the same. So instead of saying 1/4 multiplied by 39/51, we take 1/4 times 39/52. But 39/52 also reduces, so it might be better to reduce that to 3/4 first. So we end up multiplying 1/4 times 3/4, and that comes out to be 3/16. So it's exactly the same form of calculation. The only thing that happened is that second probability changed to reflect that we put the card back in first before drawing the second card. So the probability of drawing a diamond followed by a non-diamond, if you're drawing with replacement, is 3/16.